Today we're going to talk about compound assignment test within a while loop, and then we're going to talk about the second kind of loops that we're going to talk about in this class, and that is a for loop. So one of the things we did yesterday is we kind of worked on writing a menu, or one of the examples I gave, I should say, would prompt the user for a number, and it would print out that number unless the number was 0. And if the number was 0, the while statement would finish, and then our program would finish. And remember that this is because when we just provide a variable or a number inside a while statement, if it's non-zero, it's true, and if it's 0, it's false. But one of the things that we could really fix about this code is remove some repeated statements. So one of the things you can see in this code is that we scanf before the while statement starts and scanf at the end of the while statement. Now we need to do this because starting out we need to initially give choice of value. But there's actually another way we can do it. So the new and improved while menu will include an assignment and a test inside the while conditional. So I'm just going to go through and demonstrate a couple different things that we can do with a while statement. Now it actually turns out that we can assign a variable a value inside that condition. So we can say while, and then inside the parentheses we can say a equals 10, or give it any other value. So looking at, this is what we had before. So this is what we have right now. What we can actually do is we can say, get rid of this, get rid of that, get rid of this too, and we can assign choice a value right as we are testing what its value actually is. So the best way I can think of to do this is to write a quick function. So I'm going to just say get int. And all that function is going to do is read one integer from the user's terminal and store it into, and return it. So we'd say int get int a scanf a, not a, sorry, wrong way around, return a. So all this function will do is read in one integer and return it immediately. So again, what this will do is it will call the getIn function and store the value in choice. So then whatever value is returned from getInt, again, stored in choice, and that value is then immediately tested. So we can think about writing it. So this is the compact way of writing it. But another way of writing it would be something like this. We could say choice equals get int. And those are exactly equivalent. But this is just a way that we can really simplify our coding. We don't have to say choice on line 14 and choice on line 18. All we have to do is say it once in the while statement. So again, this is the simplified way we can say it. We can say choice equals get int, just like that. Now, so again, this is going to test whatever is stored in choice. And again, if it's 0, it's false, and if it's non-zero, it's true. But we can also compare it just like we can compare anything else. But in order to do that, we have to put parentheses around what we are comparing. So we need to put parentheses around this entire operation. So doing something like that, you can see here we have parentheses around our choice equals getInt, and then we could say equals 10 or greater than 0 or less than 0 or not equal to 0 or any other sorts of things. Because implicitly this is going to be not equal 0. So that's what it implicitly is. So that's just another way we can write while statements. If you see variables being assigned inside the conditional component of the while statement, that's something that's completely valid, and that's something we can do. Some people will suggest that you don't do it because it's not necessarily the most readable, but I tend to like it because, again, it removes a lot of duplicate code that we don't necessarily need. So let's say you're writing your menu function. Your menu returns the choice that the user enters. All you'd have to say is prompt the user. Let's say choice 1 is do this, choice 2 is do that, 3, 4, and so on. And then 0 is exit your program. So all you would have to say in that case is just call your menu just like you've written it before. And then you can loop through and take actions based on choice. Let's say if choice equals 1, and then take actions based on whatever choice was assigned to from your menu function. So that's just another way to write a menu function thingy. So again, this will loop through until the user enters 0, or you could say, if you want your negative case to be -1, you could say not equals -1. So does that kind of make sense to everybody? Any questions about assigning a variable inside a while loop conditional? Alright then. So on to the main thing we're talking about today. So we're going to talk mainly about for loops. So one of the things we did with while loops is we said, essentially for most of our examples on Wednesday, we said we are going to do this until the condition is true, and until the condition is false. And in order for the condition to be false, we're going to increment a variable. So we would say we're going to print out 0 to n. And what we would do is we'd say, while a is less than n, we're going to print out a and then increment a until it's less than n. And that that requires a bit of code. That would require us to do something like this. We would say while a is less than n, and my variables aren't declared, but that's fine. And we print out %i n a, and then a or plus a. So that's kind of something we refer to this kind of an operation as increment and test, because we increment a variable and then test what it's what it's equal to, less than, or do other comparison operations. But there's actually another type of loop, again a for loop in C, which combines all these operations into one construct. So a for loop would look something like this. It says for, then the first component is initialization, then a semicolon, condition, semicolon, and then increment. And then just like a while loop or a function, it's attached to a code block which executes statements when the condition is true. So the initialization is a variable assignment. So we can say whatever variable we want to, it has to be declared outside of the for loop, above the for loop before we use it. We could say I equals 0, we could say a equals 0, we could say whatever we want to. Typically with for loops, we use the letter I for index. So we would start at 0, we'd continue on, we'd say from 0 to n, which would be our condition. So our condition is a comparison. We would say I is less than 10, which would be our n, or I is not equal to 10, or I is equal to 10. And the for loop will continue on until that condition is false. But the for loop can also increment an index or a variable or whatever we want it to. We can say plus I, or I plus equals 2, or I equals I plus 2. We can give it a bunch of different mathematical operations for the increment component. It doesn't necessarily have to be addition, it can be subtraction as well. So, and then each component of this for loop is separated by a semicolon. So just, I think the next one's execution order. So the way the for loop executes is, first of all, the variables are initialized as described. So that's the red component of the for loop. And after that, the condition is tested. So that's the green component. So if it's false, we jump down to number 6, which is continue execution after the block of code. Number 3 is execute the block of code, all the statements inside. Number 4 is increment the index, which is in blue. And number 5 is we unconditionally go back to number 2. So we continue, if we test the condition, and if it's false, we jump to 6, otherwise we execute the block of code again. So the only way that we can ever exit the for loop is if the condition is false. So just keep that in mind. So here's a for loop example. So we declare 2 variables. We declare n and I. So at the beginning of the for loop, in red, we set the index I equal to 0, and then we say, while I is less than or equal to n, we're going to increment I and print it out. So again, first step is initialize the variables, that's in red. Second step is the conditional, which is in green. Then we're going to execute the printf. Then we're going to increment the index. And then we're going to continue on testing the condition again. So it essentially goes, after we started the first time, we would say we're going to test the condition, execute the statements, run the increment statement or decrement or whatever other mathematical statement we wanted to run in the third component of the for loop, and then continue doing that until the condition is finally false. And when the condition is finally false, we would continue on below the for loop. So this is just a simple example saying we're going to print 0 to n. So this should print out 0, 1, 2, 3, 4, and 5 because we're using less than equal to. If we wanted to just print 0 through 4, we'd say I is less than n, and that's it. So for versus while. So we want to use a while loop, and when you think of until, so a menu is a great place to use a while loop because we're going to keep on doing something until a certain condition happens. And the same case exists for a for loop, but we're kind of building on that. We specifically want to use for loops when we're thinking range, when we're going over a set of numbers. If we're doing an operation on each, want to do an operation each time a number, each time we go through the loop. So just a couple of examples. I'm going to do the exact same examples I did on Wednesday with the while loop. So we'll just say for.c. So declare our 2 variables. We'll scanf into n. And we'll say for I equals 0. That's our initialization. Then we say I is less than n. Then we say plus plus I to increment it at the end. And then we say printf %i, new line, and I. And that will print out 0 through 9. Now, let's say we wanted to print out, well, first of all, that's not actually outputting 0 through 10 because we need to say less than or equal to. But let's say we wanted to print out 1 through 10 instead. Instead of saying I equals 0, we'd say I equals 1. To 10. And that's going to print 1 through 10. And we can change this variable to be whatever we want it to. It doesn't have to be 1. It can be assigned to any other variable. It can be assigned to a literal. It doesn't really matter. But that's 0 through 10. So the second example is 0 through n every 2. So we would just change it, this plus plus I, instead to be a plus equals 2. So and that will print 0 through 10 going by 2. Yep.
So, is there a way to, like, stop it from running?
To stop it?
Like, skip over the for loop?
There's a couple different things, and we'll talk about them on Monday. So that's by 2. The third one we want to do is n to 0 every 1. So we're going to need to change our loop around here a little bit. We're going to say I equals, or we can actually do this one, I think, without any second variable. So one of the things we can actually do in a for loop is we don't actually have to put anything inside the initialization, the comparison, and the increment sections. We can actually leave our initialization section completely empty like that. And we could also, if we wanted to, we could leave our increment section completely empty. So all I'm going to do is I'm going to say, well, we're going to say for I greater than or equal to 0, and then we're going to decrement I. Never mind. I'm going to decrement n, because that's what I'm reading in my scanf on line 6. So that should print 10 all the way down to 0. And the reason we only need one variable in this case is because we're not going up to a variable that we read in, we're just going down to a number that we already know. So if our limits are already known, we only need one variable. So that's how we would do 0 to n in for. We could have also said something like this. We could have said I equals n. Well, I is greater than or equal to 0. And then with I. And we could have printed I. So that's what we want to do. If we still wanted to keep n at the very end, if we didn't want to modify n, we could just assign n to a new variable and use that to increment and run our for loop. So the final example is print a to z. So in order to do that one, we would say here I equals a, well, I is less than or equal to z plus plus I. And then we need to change our %i to a c for a character. And that will print a to z in a for loop. So that's for loops. Any questions on for loops as of right now?
How do you do the increments from every 1 to every 2 again?
So all you have to do is change this statement. This statement right here can be any mathematical operation. It doesn't even necessarily have to be related to the variable that you're using to compare it to or assigning it to. It could be, let's say we had a third character, a. We could say plus plus a if we wanted to. It would be a lot harder to understand, but it's completely valid. We could say, so thinking about specifically, we're going to add 2 to it. We would say I plus equals 2 instead. So we could say 3, we could say 4, we could say I equals I plus 2. We could say any of the other mathematical operations that we've talked about in the past. So that's for loops. Does that answer your question? All right. So today we're going to work on an in-class assignment. So I want you to create a program that reads in TWO, integers, x and y, prints all the integers, and prints all the integers between x and y, using a for loop, which I should say. Using a for loop. And if you want to be extra good, you should also do it inside a function. Don't really care that much, but All right then. So and then submit it to day 22 on dev.dscnix.